Hello everyone, this is a short video on how to derive dividend growth model or Gordon's dividend growth formula, which is frequently used in finance to find the equity cost of capital. So for that, I'm going to use Microsoft Paint. And imagine a firm which had just paid a dividend of amount D. Let's assume that was just now or today or yesterday, it doesn't matter. So it paid a dividend of D, so let's call it D0 based on the fact that it's paid in time 0 just now. And let's also assume that the dividend is expected to grow at a constant rate G of, let's say, 6% or 5%, whatever. I'll call it 6%. And it is expected to grow at that constant rate indefinitely, which means the dividend in year 1 is going to be today's dividend or yesterday's dividend times 1 plus growth rate. In 2 years' time, dividend will be today's dividend times 1 plus growth to the power 2. And in 3 years' time, it will be today's dividend times 1 plus growth rate to the power 3. And so on. You could go on like this indefinitely. Now, since we know the cash flows in the form of dividend in the future, we can find the present value of this share, P, which is going to be the present value of all these different cash flows indefinitely. So what we can do is present value equals this cash flow, first one, 1 plus G, divided by 1 plus the required rate of return. So let R be the required rate of return. Similarly, the present value of this whole term would be something like this: D0 times 1 plus G to the power 2 divided by 1 plus R to the power 2, and so on. So for this one, it will be D0 times 1 plus growth to the power 3 to the power 1 plus, divided by 1 plus R to the power 3, and so on until infinity. Let's call this equation 1. Now let us multiply both sides by the inverse of these two terms. In other words, I will multiply both sides by 1 plus R divided by 1 plus G. So in that case, this P looks like this: P times 1 plus R to the power divided by 1 plus G equals, so if I multiply this whole term by 1 plus R by 1 plus G, they cancel out, so what remains is D0. And in this case, in this term, if we multiply this by 1 plus R by 1 plus G, what remains is D0 times 1 plus G by 1 plus R. And similarly, instead of this power 3, this will become to the power 2. And so on until infinity. So let's call this equation 2. Now, let us subtract equation 1 from equation 2. So subtracting equation 1 from equation 2, what we get is, the left-hand side is pretty obvious, so this will look something like this: P 1 plus R divided by 1 plus G minus P. So this term minus this, because we are subtracting equation 1 from equation 2. And this is what the left-hand side will look like. So equal to, now let's copy this D0 here first. And then for these terms, they look the same, so we can cancel them out. Similarly, this term, this whole term, and this whole term can be cancelled out. And it goes on forever, and the only term remaining will be this to the power infinity, because this could be cancelled with the next term we could expect here. But as long as we assume that the R is greater than G, in which case the required rate of return is greater than the growth rate, this infinite term is going to be very close to zero. That will approach zero. So close to zero that we will simply ignore that. And this, when we subtract 1 from 2, this is what remains, ignoring the last term because that's very close to zero. So the explicit assumption here is, the assumption we're making here is that the required rate of return is greater than the growth rate. So that's the explicit assumption here. So let us shuffle this around. And what we get is P1 plus R minus P1 plus G divided by 1 plus G is equal to D0. Now further expanding this or simplifying this, what it looks like would be P times 1 is P times R is PR, minus again this P times 1 would be minus P, and minus P times G is PG. And instead of dividing this whole thing by 1 plus G, I will take this 1 plus G to the other side, so that will be something like D0 times 1 plus G, when this G goes to the other side. And we can cancel this positive and negative P, so what remains is PR minus PG here, so we can take P common, that's the market price now, and this becomes R minus G equals to the right hand side. Now we simply take this term to the other side, then the price equals D0 1 plus G, and this goes below, so R minus G. So that is the formula that we were trying to find out, the Gordon's dividend growth model. And so if you know the dividend that had just been paid, which is D0, and if you know what the growth rate is going to be in the future, the constant growth rate which never changes, and if you know the market price, you can figure out the required rate of return on equity using this formula. Now, two things. If you expect growth rate to be 0, then G would obviously be 0, this would also be 0, so what remains would be P equals D times 1, D0 times 1, and R minus 0. So this is the formula for present value of annuity. So this also makes sense. And the second thing we have to be careful about here is the R should always be greater than the growth rate. The required rate of return should be greater than the growth rate. Otherwise, this formula will not work because of the explicit assumption that we have made earlier. Here, the only way we could get this formula was when we assumed that R was greater than G. That's why the infinite term here was going to be very close to 0. If G is greater than R, this infinite term is going to be a huge number. So this formula will simply not work because our assumption is based on the idea that R is going to be greater than 0. That's right. And only in that case will this formula work. So I hope you find this formula useful.